Right, question 5. We skipped question 4. It required partial fractions. You haven't been taught that yet. That's why that's not up there. Now, I did give in the lesson one hint for this question, particularly for those of you who didn't have a mechanics background. Can anybody remind me or remind the rest of us what the hint was that I gave for this question in the lesson?
If you like differentiate, integrate A, you get. Get velocity into that.
Well, yeah, I said what acceleration was. You're sort of more or less there. I think the way I said it was acceleration, which they mentioned in this question, is how velocity or speed changes over time. So I did say that acceleration is equal to dv dt. Mechanics people, that should be very, very familiar to you. The non-mechanics people, this is the sort of thing that, and when I look at these questions, sometimes puts me off because I haven't got the mechanics background. And you need to know that acceleration is dv dt. That's one of the key things. If you don't know that, you're completely stuffed, basically, on this question. So, we know that acceleration is equal to that. So we know that dv dt equals 6 cos 2t. And in my mark scheme for this, I gave 1 mark for just putting that down, just putting 2 bits of information together.
Was acceleration of d to the dt squared?
No, it's no.
d2s dt squared.
It's how distance would change. Yes. Okay. The acceleration is how velocity changes over time. If your velocity is increasing, then you are accelerating. If your velocity is changing as time goes on, then you are decelerating. So that's the key thing there. That I then gave a mark for. Okay, so there's a differential equation. What's the first thing we've always done with any differential equations? Split it, yeah, separate the variables, okay? So anything with dv is on the top, so keep v's on the left. Anything with a t, keep on the other side. So that dt goes over there. So that's splitting it, separating the variables. Next step. Integrate. Okay? If you want to put a 1 in there to make it easier for you, then fine, do that. So, on the left-hand side, integrate 1 dv. What do we get? V. Over here, the 6, if you want, you can imagine that 6 coming through the integral sign and being written there, if that makes it easier for you. What does cos integrate to? Sine. So, what is wrong with cos 2t integrating to sine 2t?
It's over 2.
It's over
2?
Yes, that's right, yeah. Whatever the number is here, that number comes down there. That 6 stays out the front, and I've got a plus c which I put in because I've now finished my integrating. Simplify that. 6 divided by 2 is 3. That takes you down to that line there. Okay, and I have given 1 mark for getting, another mark for getting to that line, and another mark for getting to that line. So we're on 3 marks now. If we get there, there's 7 marks altogether for this question. Going back to the question, it gave us some information up the top. It said, given the velocity after pi by 4 seconds is 7 meters per second, so now I can substitute in that I've got a velocity is 7 when time is pi by 4. Then I can find out what my c is, and I can go from my general solution to my specific solution. 2 pi by 4 is the same as pi by 2. What is sine of pi by 2? Sorry? 1. Okay, so that's just 1. So I get 7 here is 3 lots of 1 plus c. So that tells me that c must be equal to 4. So now this line here, I can replace that c with a number. And I've got my specific solution. If you have got down that far, I gave 1 mark for working out that c was equal to 4, and I gave another mark then for writing down that solution. So we're now at 5 marks. Right, going back to the question again. I have done that substitution up there. Find the velocity in terms of t. Well, I've done that now. There's the velocity in terms of t. Part A is done. Part B of the question, find the initial velocity. What do I need to do to find the initial velocity? Yeah, that's right. Initial means at the beginning, at the very start. So if they're talking about the initial something, that is when t equals 0. So substitute t equals 0 in there. We get v equals 3 sine 2 lots of 0 plus 4. Sine of 0 is 0, so I get v equals 4. Okay, I ought really to put my units in, and we were dealing with meters per second. You can either write it like that, or those of you doing mechanics probably prefer writing it like that. Doesn't really matter. So I gave a mark for spotting that you had to put t equals 0 in, and I gave a mark for getting the 4 down there, so that should be a 7-mark question altogether. Okay.